Hi everyone. Okay, so I'm just doing quite a short video today as a recap, a bit of revision on how to calculate the surface area of a 3D shape. Okay, the reason I've done a video for this one is just because I know a lot of people struggle with surface area. It's really quite difficult to visualize, and that is what throws the obstacles sometimes. Some people can almost do it with their eyes closed, okay, and some of us have a little more trouble visualizing the shape. That's absolutely fine, okay, we all work in different ways. I'm going to show you two different methods, okay? Just one example for each one. Now, the first one is the way a lot of people teach this, and we look at our shape, and when we're looking for surface area, what we want to know is what is the area all the way around the outside of the shape, okay? So the base, the top, the sides, the front and the back. Okay, that's what surface area means. If we were going to cut a piece of wrapping paper to fit this shape, how much would we need exactly? So there was no overlap. How much exactly would we need? Okay, that's what the question really is asking. Now the first way, a lot of people teach this, because this is a nice regular shape here, we've got the front and the back are going to be the same area. These two sides are going to be the same area, and the top and the bottom are going to be the same area. So we can just calculate the area of each of those. So the top and bottom. Okay, so we can calculate that area. So we've got a rectangle, which is 9 centimetres multiplied by 12 centimetres. Okay, so 9 multiplied by 12, 108 centimetres squared. Okay, now just remember that's only one of them. Okay, that's just going to be the top or the bottom. So to get the top and bottom, we're going to multiply that by 2. 108 multiplied by 2. Okay, 601 and a 2. So 216 centimetres squared. That's the top and bottom. And what I'm going to do is I'm just going to mark that with a different colour. So at the end, because I'm going to have to add them all together, I can see quite quickly which ones I need. Okay, the next ones we've got are the sides. So these are the sides. Please don't be afraid. I've had a few conversations with people recently about how to approach their written maths, how to write it down. Some words are absolutely brilliant. A lot of people think because it's maths we can only use numbers. The odd word here and there make it so much easier to follow. Okay, so for the person marking it, and for you as well, it makes you a lot more organised in what you're doing, and it's more difficult for you to go wrong, to make small mistakes when you can see exactly what you're doing. It's much more organised. So we've got top and bottom there, sides here. So these sides here, 12. These are rectangles as well. 12 centimetres multiplied by 7 this time. 12 multiplied by 7. Okay, so 84 centimetres squared. Again, that's just one of them. So 84 multiplied by 2. Okay, 168 centimetres squared. That's both of our sides. And the front and back, now that's the last one, and oddly enough it's actually the trickiest one on here, just because it's not a rectangle. Okay, we've got a parallelogram here. Okay, so top, bottom, sides, front and back. Okay, so area of a parallelogram, if you can't remember, look at my video on how to find that, but it's essentially base times perpendicular height, because actually on that video it explains if we chopped off this part here, it does make a perfect rectangle. Okay, so that's why it's the same as you would need to do to find a rectangle. So we've got 9 multiplied by 6, which is our perpendicular height there. Okay, which is 54. And that's just the front or the back, and then we're going to multiply it by 2 to get both. Okay, 108 centimetres squared. Okay, so that's all of them separately. Now the last step is just to add them together. Okay, we're just going to add these three calculations, these three areas together. So we've got, I'm just going to do it here, so total, okay, which is 108, add 216, add 168. Can you see how that's a slightly different colour around my answers? Just makes it much easier to work out. So we get 8, 16, 22, 6, 8, 9, 2, 3, 4. So 492 centimetres squared. Okay, and there's your final answer for the surface area of that shape. Okay, so that's the first method. Okay, I've got a different shape to do now. It's a little tricky. There's a little more work involved. and I'm going to show you a different method. Some people much prefer this one, especially if you find it hard to visualize the shape. Some people find this much easier. Some people find it more difficult. It just depends on how you think. So we've got surface area. So we've got this triangular prism here. On the end we have got an isosceles triangle. We can see that because we've got the two lengths here that are the same. Okay, it's got a base of 8, a height of 6. So the way I'm going to show you to do this one is what we're going to do. We're actually going to draw a net. Okay, and it's going to be a sketch. I'm going to do it in pen rather than pencil just so you can see it properly. I'm going to start off by sketching the base. Okay, and that's 8 by 10, so 8 centimetres and 10 centimetres. And then coming off the sides of that base, off the side of the 10, we've got this kind of section here, and we've got the same coming up off the top. It's the other side. Okay, and that is, oh actually we've been given the measurement, which is quite nice, 7.2 centimetres long. So 7.2, and it's 10 across because it's got the same measurement as this one. And it's the same on this one. We know it's the same because it is an isosceles, okay? So those two measurements are going to be the same. Okay, and then the last thing to do are the triangles on the end. So we've got a triangle on each end, that's the front and the back, with 8 across the base and the height of, perpendicular height, oh, put that in there, of 6 centimetres. Okay, so they're identical, those triangles. And now we're just going to do the same thing we did last time, but it's just a little bit easier to see sometimes. We've got a variety of different shapes here. We've got shape A. Okay, these are both shape A, they're exactly the same shape. We've got shape B, there's only one of those. And then I'm just going to have to put this on the outside, I think. Shape C can be our triangles, and we've got 2 of those and they're the same. So we now just have to calculate those areas. Okay, so A is going to be 7.2 multiplied by 10. That's 10 centimetres. It's written here as well, just so you can see it. So 7.2 multiplied by 10, which is 72 centimetres squared. But we want to have 2A. Of course, we want 2 of them. So 2A is 72 multiplied by 2, which is 144 centimetres squared. Let's just box that one off. Okay, the next one is B, and B is going to be 8 multiplied by 10. It's just a rectangle in the middle. Multiplied by 8, which is 8 centimetres squared. And actually there's only one of those, so we don't need to multiply by 2. And that's why drawing out the net sometimes is quite helpful, okay, because sometimes people dive in and they just start multiplying everything by 2. Okay, because on a, you know, on like a cuboid or something like that, it quite often works that way, but on different shapes it's not going to. Okay, and the last one, C, which is a triangle, remember it's base multiplied by perpendicular height divided by 2. Although actually, I know you guys can follow this one, because we're going to multiply it by 2 to get 2 of them, we don't really need to divide by 2, because we're just going to undo it again. I'll show you why. Okay, so we've got 8 multiplied by 6. I'll show you why, but we'll do the divide by 2 to find one of them. Okay, which is 48 divided by 2. Okay, and then that gives us 24 centimetres squared. So 2C is going to be 24 multiplied by 2, which is 48. So because we were using 2 of them, actually, we kind of didn't need to do all of this. As long as you just kind of made it clear that's why, you know, why you'd done that, that's absolutely fine. Okay, final step is to add those 3 together. So we've got 144 plus 80 plus 48, which gives us 12 there, 8, 12, 16, 17, carry the 1, and 2. So 272 centimetres squared. Okay, so that's the last one I'm going to do. Just 2 different methods, see which one you prefer and stick with it. I'm not too concerned which one you do as long as it works for you. Okay, keep an eye on these please. Okay, make sure we're working centimetres squared for area. Other than that, off you go. Thanks folks.